This is example 1 from lesson R.2. Okay, so what we're supposed to do here is simplify each of these expressions, and they're exponential expressions, and we know they're exponential expressions because they have exponents in them. All right, so if we look at A, we have 4z to the 0 power. Now, the exponent only applies to the base that's directly in front of it, and in this case, that's going to be just the z. The 4 is not actually part of this. So anything we know raised to the 0 power is 1, so this problem is actually 4 times 1, which is going to give us 4. All right, for B, same rule applies. The 0 applies only to the exponent that's directly in front of it, and that is just the 4. The negative is not actually included in that. If it were, we'd have parentheses around the negative and the 4, showing that the 0 should be applied to the negative as well. So what I have here is negative, or the opposite, and then 4 to the 0 power is 1, so our answer here is going to be -1. All right. For C, I have 2 to the -3 power. Now remember, the way to make this positive is to take the reciprocal of the base. The base is 2, so its reciprocal is 1/2. And now we're going to raise this base to the +3 power. This is 1/2 times 1/2 times 1/2, which is going to give us 1/8. All right, now down here for D, we have a -5 as an exponent down here in the denominator. Now, we can take the reciprocal of the base here, n, and turn it into 1 over n, and this is to the +5, and then we've got a fraction inside of a fraction, and we'll have to turn this into a division problem of fractions, and then make it a multiplication problem, and it's really, it's a lot of time and effort to do that. So if we apply the rule that says if you cross the line, you change the sign, then what I'm going to do is I'm going to take the negative exponent and the base that it's attached to, and I'm going to cross the line right here, the line being the division sign right here. And I'm going to turn this into 1 times n to the +5 power, and then there's nothing left down here on the bottom, but I'm going to put the 1 placeholder down here. And then when I simplify this, we're just going to have n to the +5 power, because 1 times n to the +5 is n to the +5, and then n to the +5 divided by 1 is just n to the +5. So remember, if you cross the line, you can change the sign. That only works when the exponents are negative. So you'll look at E right here, and I have a negative exponent on the B. The exponent on A is positive, so it's going to have to stay where it is. And then I have a -3. Now this is not an exponent, which means that the -3 has to stay where it is. So right now, all of this is divided by 1. I'm going to take the -9 exponent and the base that it's attached to and move it down into the denominator with my 1. And that's going to turn this into -3 times A to the +4 power. And on the bottom, we'll have 1 times B to the +9 power. So this is going to be -3A to the +4 divided by B to the +9.